This is the equation of displacement of SHM. Equation of SHM, equation of displacement of SHM, where A is equal to amplitude, omega is equal to 2 pi by upon t. This is called angular frequency, and the quantity omega t plus phi, that is the angle of sine. This is called the phase, and if in this case t is equal to 0, phase become 0 plus phi, and this is equal to phi, and this is called initial phase. Initial phase. Now we give some definition. For example, amplitude. What is amplitude? When a particle performs SHM about the mean position, suppose this is the mean position, and it go up to the maximum displacement in the positive direction, and this is the maximum displacement in the negative direction, and this is the mean position. So the maximum distance of the particle from the mean position is called amplitude. So the definition of the amplitude can be written as the maximum distance from mean position is called amplitude. In this case, this is the amplitude plus this the amplitude. ध्यान रखने वाली बात है, एम्पलीट्यूड जो पॉजिटिव क्वांटिटी होती है ना, डिस्प्लेसमेंट नहीं है, डिस्टेंस है ये. सेकेंड थिंग इज टाइम पीरियड. What is time period? The time period is what? Time taken by particle to complete one revolution is called time period. Revolution, or it is better to write oscillation, not revolution. Oscillation is called time period. And it is represented by capital T. For example, in this case, if we consider the motion of the particle at t is equal to 0, particle is here at the mean position, and it will go to the maximum displacement first, then it will come back to the mean position, okay, then it will go to the maximum displacement in negative direction, and then it will come back to the mean position. So this is how the particle is doing motion. So इस पॉइंट से लेकर के जब वो पार्टिकल ऐसे जाता है, दिस इज कॉल्ड द राइट एक्सट्रीम पोजीशन, and then it come back to the mean position again, and then it go to the left extreme. Then it go to the mean position. तो t is equal to 0 से लेके t is equal to time तक, it complete one oscillation about its mean position. Therefore this time period is called the time period, isn't it? Next, frequency, angular frequency. Angular frequency. What is angular frequency? It is represented by omega, and mathematically it is equal to f, and it is equal to 2 pi by t, where t is equal to frequency is equal to 1 by t. Unit is second per inverse of per second. We can also write. Second thing, what is frequency? Is the number of oscillation in 1 second. This is called the frequency, isn't it? So we have discussed the initial phase. Let's see some more depth, the equation of displacement of the particle. For example, this is the equation of displacement of particle performing SHM. And this is nothing but, it is not a new special, this is the same thing. Xt is equal to A sine omega t plus phi. For meantime, suppose at t is equal to 0, particle is at mean position, and mean position is our x is equal to 0. So if you take A sine omega t, since t is equal to 0, therefore this is phi, and it become sine phi is equal to 0, implies that initial phase phi is equal to 0. Therefore, in a simple way, the equation of SHM of displacement of a particle can be written as phi to 0 हो जाएगा, and it is equal to sine omega t. Or maybe it is better to write in a way sine 2 pi by t into small t, where t is the time period, isn't it? So this is the equation of the displacement SCC. Now we look about the motion of the particle at t is equal to 0. At t is equal to 0, if you want to find the displacement 0, sine 0 is equal to A sine 0, and it become to 0. That is, if we consider the particle performing SHM, and this is, suppose this is x-axis, and this is x is equal to 0. So at t is equal to 0, the particle is over here. Okay, if we consider at t is equal to t by 4, the particle at t is equal to t by 4 is equal to A sine, put the value of t in this expression, and you will get the value of displacement of the particle from mean position, and it is equal to A sine pi by 2. That is, it equal to plus A. It means what? It means at t is equal to t by 4, the particle is at this position. Okay, initially तो t is equal to 0 पर था. कैसे जाएगा? पहले तो वो इस टाइप से जाएगा, है ना? It will move like this into t by 4 and reach over here. Now if we consider at t is equal to t by 2, the displacement of the particle, if you see, this is equal to A sine 2 pi by t. दिस इज एक्स टी डिस्प्लेसमेंट ऑफ ए पार्टिकल एज ए फंक्शन ऑफ टाइम टी। तो यदि आप कैपिटल टी बाई टू पर आधे टाइम पीरियड पर इसका डिस्प्लेसमेंट निकालना चाहते हो, देन यू विल पुट द वैल्यू ऑफ टी इन दिस एक्सप्रेशन, एंड टी से टी कैंसिल हो जाएगा, इट विल इक्वल टू साइन पाई एंड इज इक्वल टू जीरो। दैट इज इट कम्स अगेन टू द मीन पोजिशन एट टी इज इक्वल टू कैपिटल टी बाई टू। Now if we see at t is equal to 3t by 4 x 3t by 4, if you put the value and you will get sin 2 pi by t 3t by 4, and it is equal to a sin 3 pi by 2, and it is equal to minus a, because sin 3 पाई बाई टू की वैल्यू कितनी होती है, साइन 3 पाई बाई टू इज इक्वल टू साइन पाई प्लस पाई बाई टू, एंड इट इज इक्वल टू माइनस वन। सो नाउ इट इज मूविंग टू लेफ्ट एक्सट्रीम। पहले यहाँ पर था पोजिशन, फिर पार्टिकल यहाँ आया, फिर पार्टिकल यहाँ पर आएगा लेफ्ट एक्सट्रीम पर, है ना। और इस पॉइंट पर आने के बाद सपोज ये है लेफ्ट एक्सट्रीम, दिस लेफ्ट एक्सट्रीम माइनस ए, दिस इज प्लस ए, एंड इट कम टू इस पॉइंट एट टी इज इक्वल टू 3t बाई 4 पर, है ना। अब यदि आप अगेन एट टी इज इक्वल टू 3t बाई टी पर देखते हो, तो एक्स टी की जो वैल्यू आएगी वो a साइन 2 पाई बाई टी इंटू टी, दैट इज साइन 2 pi into a is equal to 0. Then again it will move to the mean position. So actually what is happening in this case, what is happening, so as we are seeing that पहले जब पार्टिकल मूव करता है तो t इज इक्वल टू 0 पर तो इस पॉइंट पे रहता है, और t इज इक्वल टू टी बाई 4 पर लेफ्ट एक्सट्रीम पे जाता है, ऐसे करके प्लस a पे जाता है। देन t इज इक्वल टू टी बाई 2 पर फिर अपना दोबारा से पाथ बदलता है ना, और वेलोसिटी की डायरेक्शन चेंज करके मीन पोजीशन तक आता है। देन आफ्टर इट विल मूव एट टी इज इक्वल टू 3t बाई 4 पर माइनस ए की ओर जाता है। देन इट विल मूव अगेन टू टी इज इक्वल टू कैपिटल टी पर एक्स इज इक्वल टू 0 पर पहुँच जाता है। सो दिस इज हैपनिंग इन द